Basic Concepts in Statistics. This is Sir Haran Bautista, your math teacher. I hope you have to pay your attention while I'm discussing things to you all throughout this video. Let's begin with the key concepts used in statistics. The first one, we have population. It is just a well-defined group of people, objects, materials, events, or things of any form. To understand it more clearly, here is an example. The age of each provincial governor. In the example, we're dealing with a group of governors in the Philippines. Therefore, this is about population. Basta, it deals with a group of anything defined here in the definition given. Next, sample, it is a sub-collection of elements drawn from the population, meaning to say, sample is just a portion or a part of a population. And here is the example. The age of provincial governor in Region 3. So here we're dealing with the group of governors only located on Region 3. But we all know that Region 3 is just a portion of the Philippines. Okay? It's part of all regions of the Philippines. This one of the regions. Therefore, the example here talks about example. Next. Census. So it is a collection of data from every element in a population. So it's gathering every single data from each member of a population, just like what the National Statistics Office, now so-called the Philippine Statistics Authority, did in our country. So they are conducting yearly census. Okay? Next, we have the survey. So survey is an act of studying something in order to gather information about what most people do or think about. For example, in layman's terms, survey is just knowing the pulse of people. Okay? Knowing the pulse of people. For example, you are conducting survey. You're asking people, what vaccine do you prefer? Okay? So you're just asking anything you need to ask. So that is a survey. So you're just asking questions and knowing their answers. Okay, so that is now the definition of these four concepts used in statistics. Now let's proceed. Now let's talk about the two major areas in statistics. First, we have descriptive statistics. It is just a method concerned with describing the properties and characteristics of a set of data. So it describes by using single number to represent the whole data. To illustrate, here is an example. So a sanitary store owner records the frequency of sales of the three leading detergent soaps. For example, for detergent A, 12 pieces of this has been sold. For detergent B, 20 pieces has been sold for that day. And for detergent C, 10 pieces has been sold. So these numbers can describe each data here. So 20 is a number describing the sales of detergent B. So how can we describe this? So the description here is detergent B has the most number of frequency of sales. Detergent C has the least number of frequency of sales. Or detergent B is the most in-demand detergent soap in the place of the sari-sari store owner. So we are just using the numbers in describing the set of data. Okay, so that's about descriptive statistics. Now let's proceed to the second major area. The next major area is inferential statistics. So it is just a method concerned with the analysis. So you are just analyzing the sample data leading to or that will result to the prediction, inferences, interpretation, or conclusion. So these four are just the same. They are synonymous. So about the entire population. So when you analyze the data, you will lead to this for example. And of course, it also involves drawing of conclusions or decisions about the population based on random samples. So for example, a teacher computes the mean score of her class in mathematics test to determine if the class mean is significantly related to their scores in a science test. So, it deals with computing the mean score. So, if the example is just up here, kung dito lang yung example, a teacher computes the mean score of her class in mathematics test. Kung hanggang dyan lang ang example, that is just a descriptive statistics. But, meron siyang continuation to determine if it is significantly related. So, there is a comparison. So, the teacher analyzes. So, he did an analysis by comparing the result of the mathematics test to the science test. Kung meron ba silang relasyon, may pagkakaiba ba? So, there's an analysis. So, this example or this action is a best example for inferential statistics. Basta, you are analyzing, you are using numbers, you're comparing numbers. So you're still using numbers, but you are comparing that numbers to other values or other numbers. There's a comparison. Okay? So that is inferential statistics. Next, we have the nature of variables. First, we have here quantitative data. So data are variables. They are just the same. So it refers to numerical information obtained from counting or measuring. Okay, so it just talks about numbers. Numbers, so that is quantitative data. Here are some of its example. We have here age, height, and weight. Both of these three examples deals with numbers. So these are quantitative data. Quantity, numbers. Next, qualitative data. It refers to descriptive attributes or characteristics that cannot be subjected to mathematical operations. In short, it talks about description that will describe the variables, the objects, or whatsoever you're studying. Okay? So examples, we have here gender, we have that is male or female, citizenship, Filipino, American, Japanese, Korean, and so on and so forth. Then the marital status, we have single, married, widowed, or separated. So these are examples of qualitative data. Talks about quality, which we cannot subtract or we cannot add since it's just about description. So these two are the nature of variables. Okay. Next, we have the types of quantitative data. So the first type is discrete variable. So variable or data, which I have told you a while ago, they are just the same. So variables that can be obtained by counting. So we can count this using our fingers. Examples, the number of computer in a laboratory. So the number. So we can count the number of computers, right? Using our fingers. We can count them. Next, we have continuous variable. Variables that can be obtained by measuring objects or attributes. So we cannot count this because we are just going to measure these things using some tools. Example, weight, temperature, and area. So weight, we're just using weighing scale. For the temperature, we're just using some tools for this, right? Okay, so these are the types of quantitative data. Next, scales or levels of measurement. Okay, scales or levels. So first we have nominal. Nominal scale. So the data is only consisted of categories. So categories. Data cannot be arranged in an ordering scheme, and standard mathematical operations are not defined. Meaning to say we cannot add, subtract, multiply, or divide the said data. Examples of this data, or this scale rather, name, label, colors, gender, geographic location. So as you can notice, the examples related to nominal, under nominal scale, are just qualitative data, right? Talks about quality or characteristics. So we cannot add a name, we cannot subtract the name. We cannot also arrange them from in ascending order or in descending order, right? Next, ordinal scale or ordinal level. So the data here is consisted of categories. Okay, just the same with the nominal data or nominal scale. But in this one, we can arrange this data accordingly. So, according to the relative size or quantity. But the difference between data are meaningless. So, there is no difference. So, there is no meaning. So, it is not important. It doesn't matter if we differ. Okay, if we compare them. Examples. Customer ratings of service might be 1, 2, or 3, where 3 is excellent and 1 is unacceptable. So, as you can see, each number has its own description, and each description can be arranged accordingly. Okay, 1 up to 3. So 1 is unacceptable, and then 3 is excellent. So 1 is the lowest and 3 is the highest. So we can arrange them. So there is an order. So it's ordinal scale. Okay? So it talks about categories which can be arranged accordingly. Next, we have interval scale or level. So let's proceed with the example itself. Score on subject content exam. So we'll be defining this scale by using this example. So both ordering and computing differences can be meaningfully applied to the data. So if are handling the class, so in a class of 40 students, so there will be a varied scores, right? The scores will vary. So we can arrange the scores of the students in ascending or in descending order, from lowest to highest or from highest to lowest. And the difference between those scores are meaningful. For example, Roberto got 20 out of 30 items, and Alan got 25 out of 30 items. So, therefore, Alan got 5 points higher than Roberto. So there is a meaning. Next, differences between values are meaningful, just like what I have said a while ago, but there is no natural starting point. Diba? Score is unpredictable. There is no starting point. It talks about chances. Okay? There is no starting point. Okay. The 0 point on a strictly interval label does not correspond to the absence of the quantity being measured. So, for example, one of the students got 0 score. So that 0 does not mean there's an absence of something. There's an absence of a score. Since that is also a score which has a meaning itself. Right? It has its own meaning, even if the value is 0. And then ratios are meaningless. So when you say ratios, that is the division. You are going to divide or something like that. So when you divide the score of Roberto to Alan and Alan to Roberto, there is no meaning out of that. So that is interval scale. Next, we have ratio, scale or level. So we have your weight and height. So the data can be meaningfully ordered. Yes, of course, we can order the height in ascending, right? The weight and the height. Both arithmetic differences and ratios are meaningful. So we can add the weight and the height. We can subtract it. We can multiply and even divide, right? Okay, like the interval scale, but there is a natural 0 starting point. So when the weight is 0, there's an absence of weight, right? If the height is equal to 0, there is no height anymore. There is an absence. So there is a natural 0 starting point. Ratios are meaningful. So how can we say that ratios are meaningful? For example, the weight of Alan versus the weight of Roberto. So we can divide their weight, okay, and get the percentage. Okay, we can get the ratio 1 is to 2, 3 is to 4, just like that. Okay, we can compare the values for the weight, okay, and the height. So that is ratio. So when we talk about ratio scale, we can add, we can subtract, we can multiply, and even we can divide the data, the values of the data. It talks about numerical values. Okay, so it's the last part of scale or levels of measurement. So that's all about the basic concepts of statistics. So I hope you learned something, you get something from my discussion, and I hope that it will help you in understanding your topic, your future topics in Practical Research 1. Thank you for your time.